This is Lecture 1 of Module 3. Disposing of the sewage effluents. There are two general methods of disposing of the sewage effluents. First one is dilution. That is, disposal in water. Second one is effluent irrigation or broad irrigation or sewage farming. That is, disposal on land. Out of these, disposal by dilution is more commonly used. We are going to see them in detail. Disposal by dilution. Disposal by dilution is the process whereby the treated sewage or the effluent from the sewage treatment plant is discharged into a river stream or a large body of water such as a lake or sea. The discharged sewage in due course of time is purified by what is known as self-purification process of natural waters. The degree and amount of treatment given to raw sewage before disposing it off into the river stream will definitely depend not only upon the quality of raw sewage, but also upon the self-purification capacity of the river stream and the intended use of its water. So in disposal by dilution method, sewage is discharged into a river stream or a large body of water. Next, we will look into what are the conditions favoring disposal by dilution. When sewage is comparatively fresh. Fresh sewage means it is 4 to 5 hours old. And free roam floating and settleable solids, we prefer disposal by dilution. When the diluting water has a high DO content. Diluting water means source of disposal. If the water has high DO content, we prefer disposal by dilution. Next point is, where diluting waters are not used for the purpose of navigation or water supply for at least some reasonable distance on the downstream from the point of sewage disposal. That is, if the water source is not used for navigation and water supply, also it is at reasonable distance from the point of disposal. Disposal by dilution is used. When the outfall sewer of the city or the treatment plant is situated near some natural waters having large volumes and where the flow currents of the diluting waters are favorable, causing no deposition, nuisance or destruction of aquatic life. So these are the conditions favoring disposal by dilution. The table shows the standards of dilution based on Royal Commission report. It says that if dilution factor is above 500, no treatment is required for the sewage. That is, raw sewage can be disposed of directly. If the dilution factor is between 300 to 500, only after primary treatment we can dispose the sewage. Primary treatment includes sedimentation. If the dilution factor is between 150 to 300, treatments such as screening and sedimentation, also chemical precipitation, are required. If the dilution factor is less than 150, complete thorough treatment should be given to sewage. Only then we can dispose sewage by dilution method. Dilution in rivers and self-purification of natural streams. When sewage is discharged into a natural body of water, the receiving water gets polluted due to waste products present in sewage effluents. But the conditions do not remain so forever because the natural forces of purification such as dilution, sedimentation, oxidation, reduction in sunlight, etc., go on acting upon the pollution elements and bring back the water into its original condition. This automatic purification of polluted water in due course is called self-purification phenomenon. When sewage is discharged into a natural body of water, the receiving water gets polluted due to waste products present in sewage effluents. But the conditions do not remain so forever because the natural forces of purification such as dilution, sedimentation, oxidation, reduction in sunlight, etc., go on acting upon the pollution elements and bring back the water into its original condition. This automatic purification of polluted Water in due course is called self-purification phenomenon. The various natural forces of purification, which help in effecting self-purification process are: first one is physical forces. This include dilution and dispersion, sedimentation and sunlight. Second one is chemical forces. It includes oxidation and reduction. We will look into them in detail. First one, dilution and dispersion. When the putrescible organic matter is discharged into a large volume of water contained in the river stream, it gets rapidly dispersed and diluted. The action thus results in diminishing the concentration of organic matter and thus reduces the potential nuisance of sewage. If Cs is concentration of sewage, Qs indicates rate of flow of sewage, Cr concentration of river stream, and Qr rate of flow of river, and C represents concentration of resulting mixture, then we have a relation Cs into Qs plus Cr into Qr equal to C into Qs plus Qr. From that we get concentration of resulting mixture. C equal to Cs into Qs plus Cr into Qr divided by Qs plus Qr. This is an important equation. Then, problem 1. The sewage of a town is to be discharged into a river stream. The quantity of sewage produced per day is 8 million liters, and its BOD is 250 mg per liter. If the discharge in the river is 200 liters per second, and if its BOD is 6 mg per liter, find out the BOD of the diluted water. Quantity of sewage produced per day is 8 million liters. So it is the quantity of sewage discharged into the river. So, sewage discharge, Qs is equal to 8 million liters. Convert into liters per second. Million liters is converted to liters by multiplying by 10 raised to 6. And day is converted into second by multiplying 24 into 60 into 60. We get 92.59 liters per second. If the discharge in the river is 200 liters per second, it means discharge of the river, Qr is equal to 200 liters second. In the question it is given, BOD of sewage is 250 mg per liter. That is Cs equal to 250 mg per liter. Also BOD of the river, that is Cr, equal to 6 mgl we want to determine the BOD of the diluting water. Therefore, concentration of resulting mixture, C equal to Cs into Qs plus Cr into Qr divided by Qs plus Qr, just substituting the values, we get BOD of the diluted mixture as 83.21 mg per liter. Next, problem 2. In problem 1, what should be the river discharge if it is desired to reduce the BOD of diluted water to 20 mg per liter? So here in this question, value of C is given as 20 mg per liter, and we want to determine the river discharge. All other parameters are same as the problem 1. So, in the same equation, substitute all other values and we will get river discharge as 152 liters per second. Next physical force, which help in self-purification process, is sedimentation. The settleable solids, if present in sewage effluents, will settle down into the bed of the river, near the outfall of sewage, thus helping in the self-purification process. Sunlight. The sunlight has a bleaching and stabilizing effect of bacteria. It also helps certain microorganisms to derive energy from it and convert themselves into food for other forms of life, thus absorbing CO2 and releasing oxygen by a process known as photosynthesis. The evolution of oxygen in river water due to sunlight will help in achieving self-purification through oxidation. Oxidation. The oxidation of the organic matter present in sewage effluents will start as soon as the sewage outfalls into the river water containing dissolved oxygen. The deficiency of oxygen so created will be filled up by the atmospheric oxygen. The process of oxidation will continue till the organic matter has been completely oxidized. This is the most important action responsible for effecting self-purification of rivers. Reduction. Reduction occurs due to hydrolysis of organic matter settled at the bottom either chemically or biologically. Anaerobic bacteria will help in splitting the complex organic constituents of sewage into liquids and gases, and thus paving the way for their ultimate stabilization by oxidation.